Good morning, class. So today we're looking at the exercise 2 on exponential and log functions. Logarithmic. You what page are we on? 52. Exercise 2 is on page 52. We said we're going to do the odd numbers only. Okay. So the question says, write these logs in exponential form. So as we know, we're going to take that 5 onto the 2. So it's 2 to the 5 is equal to 32. Or 32 is equal to 2 to the 5 is the same. 1.3, the negative 4 goes on to the 3, and of course that on its own. So 3 to the negative 4 is equal to 1 over 81. The next one, negative 6 onto the half, 64 on its own. So 64 is equal to half to the negative 6. And all of that can be tested on your calculator. That we know it's 32. So that's going to be 2 to the minus 1 raised to negative 6. It will be 2 to the 6, which is 64. And that's going to be 1 over 3 to the 4, which is 1 over 81, which is correct. Number 2, they say write these exponents in log form. So we know that the exponent will be the exponent will be the subject. So 4 is equal to log 16 base. 16 can be written as 2 to the 4. That 4 can be written in the front. So it's 4 log 2 base 2. Log 2 base 2 is 1. 4 times 1 is. The next one, again you're going to make y the subject, with the exponent the subject of the formula. So y is equal to log x base 2. Here as well, we have 2 is equal to log 5 base 8. Number 3.1. Number 3, we're told to solve for x by applying the logarithmic definition. We do not require a calculator. Calculator should not be used in other words. So that goes on to the x and that on its own. So x squared is equal to 25. If I introduce square root, I must not forget plus minus. So x is equal to 5. Why 5 and not plus minus 5? X must be more than 0. X must be positive. Okay, the next one, that goes on to the 2, that on its own. So 2 to the x is equal to 128. 128 can be written as 2 to the 7, I think. Whoops. 128. 2. Is equal to shift 2 to the 7. So 2 to the x equal to 2 to the 7. Therefore, x is equal to 7. The board can feel that it's weakened. No? It doesn't work any longer. Okay. So 5 to the x equal to 1 over 125. Well, 125 can be written as 5 cubed. That's numerator, denominator. So I must bring that one up or that one down, doesn't matter. So 5 to the x equal to 5 to the negative 3. Therefore x equal to negative 3. Okay. Any confusion there? No? Solve for x by applying the log definition. You are correct to 2 decimal places. Let's go with logs here. X is equal to log 5 base 2. So we say log 5 base 2 gives you 2 comma 3. Okay. So what we do first? We divide by 14 both sides. We want the exponential form to be ax to the equals b. That's the form we want, so that we can write in log, in log form. So it's going to be 2 to the x minus 2 is equal to 25 over 7. Or you can leave it as 50 over 40. Okay? So what do we get now? That must be the subject of the formula, not so? So therefore x minus 2 is equal to log 25 over 7 base 2. Then I can put that in the calculator, then add 2 to it. So it's going to be log 25 over 7 base 2 plus 2. Okay. You don't need a bracket then. So be log 5 over 27, 50 over 14, doesn't matter, plus 2. Separate from that, plus 2. What will give us? 3,84. So x is equal to 3,84. And of course we can test it, people. If I now substitute 3,84 into that part of the equation, what should the answer be? What should the answer be? 50. So it's 14 times 2 to the exponent x, which is 3,84 minus 2. Gives you exactly 50. If you had typed in the calculator 3.84, since this is a rounded off answer, it's going to give you an answer very close to 50. You see 50,12, which is also correct. Okay? Okay, the next one. What do we have to do first? Divided by 3. So 5 is equal to 1.2 to the x. You all agree with that? So 1 plus 0,12 is 1,2 to the x. Now I can apply the log again. So therefore x is equal to log 5 base 1.2. Here we go, log 5 base 1.2 gives you 8, 8. Is that correct? .7. Here we must change to exponential form. Can you see that? To solve x. So the 3 goes onto the x and that goes onto its own. Because x cubed is equal to 64. I take the cube root both sides. So x is equal to 4. Will you agree with that? Go to the next one. The 1 onto the 2, so 2 to the 1 is equal to x squared minus x. Take that over, so 0 is equal to x squared minus x minus 2. Try no more. So you got 0, x, 2 and 1. So this one must be negative, positive. So therefore x is equal to 2 over x is equal to negative 1. I think it will be safe for us to test if it works. Because as we know that this here, which is x squared minus x, has to be greater than 0. Alright, so we got x into x minus 1 must be greater than 0. So your critical values here is 0 and 1 must be greater than. So my solution says x must be less than 0 or x must be greater than 1. Is that less than 0? Yes. Is that greater than 1? Yes. So both these solutions. Did the textbook omit one of the solutions? They considered both. Okay. And in the example, they omitted one, and I still can't figure out why. But if you have this, the reason for it, please let me know. Okay. Otherwise, the full lesson can be found. The explanation to the examples can be found in the description box below. That brings us to the end of exercise 2.